Okay, in number 14, we need to find the least common multiple or least common denominator here that we can multiply through by. So we'll say this is going to be y plus 2 times y minus 1. Since the denominator of 4 is just 1, these are your two factors that we can multiply through by. So if you want to see it all written out, it's just going to be y plus 2 times y minus 1 times 4y over y plus 2 plus y plus 2 times y minus 1 times 2 over y minus 1 equals 4 times y minus or y plus 2 times y minus 1. Okay, in the first expression, the y plus 2's cancel, so we're left with 4y times y minus 1. In the second expression, the y minus 1's cancel, and you're left with a positive 2 times y plus 2. And on the right side, nothing cancels, so we need all of it. Okay, now we just do the math, multiply it all out. 4y times y is 4y squared minus 4y, distributive property, plus 2y plus 4. Now we can keep our 4, we can FOIL the y plus 2 and the y minus 1. That will give us y squared minus y plus 2y minus 2. Let's combine like terms over here. 4y squared minus 2y plus 4. And we can combine like terms over here. Y squared plus y minus 2. We can distribute through the 4, so 4y squared plus 4y minus 8. And just copy down what was left on the left side. Since we have 4y squareds on both sides, they cancel out. So we just have negative 2y plus 4 is equal to 4y minus 8. Let's add the 2y to the other side, and we get 6y minus 8. Add the 8 to the 4. 6y is equal to 12. So y is equal to 2. Now we need to set our domain. Our domain is going to be all values of x, actually we're using y again in this situation, y such that y cannot equal. In this expression, negative 2 would make this denominator 0, so y cannot equal negative 2, and y cannot equal positive 1 for this denominator. So the domain includes every number except for negative 2 and 1. Since 2 is not either of those numbers, 2 is a good solution for this problem. Okay, in number 15, we need to factor the denominator first so we can find our common factor to multiply through by. X minus 1 and x plus 1, since that's a difference of two squares. And then we have x plus 1 and x. So what I can multiply through by is x minus 1, x plus 1, and x. And that includes these two terms because the x plus 1 is included here, but I need the x. So I'm going to multiply everything by x minus 1 times x plus 1 times x. Alright, if I multiply all of this by this first term, the x minus 1 and the x plus 1 are going to cancel, so I'll be left with 5 minus x times just the x. Keep my plus sign. The x plus 1 would cancel with this x plus 1 for this term, so I'd have to multiply the 7 by everything except for the x plus 1. So 7 times x minus 1 times x. And in this expression, I have to multiply by all of it, so the x's end up canceling. So I have to multiply 6 by everything but this x that just cancels, which is x minus 1 times x plus 1. Now I can do my distributive property and simplify my expression and get an answer here. So I'm going to distribute my x, and I'll get 5x minus x squared. Distribute I can put this x with my 7, so I can make this a 7x times x minus 1 and distribute the 7x through, and I get a 7x squared minus 7x. And then I can do the difference of squares here, which is x squared minus 1. If you don't remember how to do that quickly, it's just this expression right here, because these were the factors of x squared minus 1. And then I can distribute my 6x squared minus 6. Combine some like terms over here, negative x squared and a 7x squared is a 6x squared minus 2x. The 6x squareds end up canceling, so I'm left with a negative 2x equals negative 6. So x will end up equaling 3. I need a domain, so my domain will be x such that x cannot equal, and then we need to go to the numerators or the denominators and see what makes these 0. So in this part of the denominator, 1 makes this 0, so x can't equal 1. In this denominator, x plus 1, a negative 1 would make that 0, so x cannot equal negative 1. In this denominator, negative 1 again makes it 0, so since I already have it written, I don't need to write it again. But this denominator has just an x, so the number that makes that 0 is 0, so x cannot equal 0. So our domain cannot include positive and negative 1 and 0. Since 3 does not qualify, it is a solution to this problem.